Hey everybody, welcome. I'm going to get into some Ethereum 2.0 information today. The documents that I'm pulling from are from ethos.dev. First thing I'd like to explain about Ethereum is the beacon chain, Ethereum 2.0. And before we can really get into the beacon chain of Ethereum, we really need to begin to understand sharding. So sharding, a big picture. To appreciate the beacon chain, an introduction to sharding helps. The main problem in scalability in blockchains, including Ethereum, that they currently face is every node has to verify and execute every transaction. In computer science, there are two main approaches to scaling. One, scaling vertically, basically making nodes more and more powerful. Or two, scaling horizontally, basically adding more nodes. For decentralization, blockchains need to scale horizontally. A goal of Ethereum 2.0, also called ETH2 or Serenity, is for nodes to run on consumer hardware. Sharding is the term for horizontally partitioning a database. Generally, a shard chain has a subset of nodes processing it. Virtual miners, validators, are assigned to shards and only process and validate transactions in that shard on that specific chain. Ethereum shards have a dynamic subset of nodes processing it block by block. The main challenge with sharding in blockchain is the security of shards, since validators are spread out across multiple shards. One way we can solve this problem is randomly shuffling the validators, where every shard block has a pseudo randomly chosen committee of validators, ensuring that it is mathematically improbable that an attacker controlling less than 1/3 of all validators can attack a single shard. Fraud proofs, custody proofs, and data availability checks are also important security components, but require their own explainers later on. We'll do that in another video. The current ETH2 plan is for 64 shards. Although shards are separate from the beacon chain, we'll describe some key elements of the overall system. Sharding has revealed clues about what the Ethereum beacon chain does and needs. It's important for us to understand the Ethereum 2.0 phases. Briefly, Ethereum 2.0 has 3 phases. Phase 0, the beacon chain, Phase 1, shards, and Phase 2, execution. Let's talk about slots and epochs. The beacon chain provides the heartbeat to Ethereum 2.0. It provides the tempo and rhythm for the system's harmony and consensus. Each slot is 12 seconds, and an epoch is 32 slots. That's 6 minutes and 24 seconds. The first 32 slots of Epoch 0 Genesis block are at slot 0. A slot is a chance for a block to be added to beacon chain and shards. You can imagine that beacon chain and shard chains are choreographed in lockstep. Every 12 seconds, one beacon chain block and 64 shard blocks are added when the system is running optimally. A slot is like the block time, but slots can be empty. Genesis blocks for the beacon chain and shards are at slot 0. Shards will start at a different epoch than the beacon chain's epoch 0, but will have their own epoch 0 that includes their Genesis blocks. An introduction to validators, attestations, and beacon chain. While proof of work is associated with miners, in Ethereum 2.0, validators are proof of stake, virtual miners. Validators are actively participating in the consensus of Ethereum 2.0. We will discuss their incentives later when we talk about validator rewards and penalties. A block proposer is a validator that has been pseudo-randomly selected to build a block. Most of the time, validators are testers that vote on beacon blocks and shared blocks. These votes are recorded in the beacon chain. The votes determine the head of the beacon chain and the heads of the shards. A random validator proposes a block for each slot. The validator receives a reward if other validators vote for this proposed block. Note, slots may be missing from a block. This happens when the assigned validator does not process a block for reasons such as being offline or out of sync with the rest of the network. A validator would miss out on that reward. In this example, we'll say we see a missed proposal for some epoch's 28th slot. At every epoch, a validator is pseudo-randomly assigned to a slot and shard. The validator is participating in the consensus of that assigned shard so that it can vote for that shard's head. The validator links the shard head to the beacon block for a slot. And attestation is a validator's vote, weighted by the validator's balance. Attestations are broadcast by validators in addition to blocks. Validators also police each other and are rewarded for reporting other validators and make conflicting votes or propose multiple blocks. The contents of a beacon chain is primarily a registry of validator addresses that state each validator, attestation, and links to shards. Validators are activated by the beacon chain and can also transition to states. Staking validators. Validators are virtual and are activated by stakers. In proof of work, users buy hardware to become miners. In Ethereum 2.0, users stake ETH to activate and control validators. It is clearer to associate stakers with a stake and validators with a balance. Each validator has a maximum balance of 32 ETH, but stakers can stake all of their ETH. For every 32 ETH staked, one validator is valid. It is clear to associate stakers with a stake and validators with a balance. Each validator has a maximum balance of 32 ETH, but stakers can stake all of their ETH. For every 32 ETH staked, one validator is activated. Validators are executed by validator clients and make use of the beacon chain node. The beacon node has the functionality of the following in reading the beacon chain. Validators are executed by validator clients that make use of the beacon chain node. The beacon node has the functionality of following and reading the beacon chain. A validator client can implement beacon node functionality or make calls into beacon nodes. One validator client can execute one or more validators. Crosslinks, routing shards to the beacon chain. A crosslink is a reference in a beacon chain block to a shard block. A crosslink is how the beacon chain follows the head of a shard chain. As there are 64 shards, each beacon block can contain up to 64 crosslinks. A beacon block might only have one crosslink, if at that slot. There are no proposed blocks for 63 of the shards. Crosslinks are planned for ETH2 Phase 1 to route the shard chain into the beacon chain, serving as the base or the standard fork choice, shard chain finality, and for cross-shard communication. All shard chains are following the beacon chain at all times. An introduction to committees. A committee is a group of validators for security. Each slot in the beacon chain and each shard has committees of at least 128 validators. An attacker has less than 1 in a trillion probability of controlling 2/3 of a committee. The concept of a randomness beacon that emits random numbers for the public lends its name to the Ethereum beacon chain. The beacon chain enforces consensus on a pseudo-random process called RANDAO. At every epoch, a pseudo-random process, RANDAO, selects proposers for each slot and shuffles validators to committees. Proposers are selected by RANDAO with a weighting on the validator's balance. It's possible a validator is a proposer and a committee member for the same slot, but it's not the norm. The probability of this happening is 1 out of 32, so we'll see it about once per epoch. It's important to note that at every epoch, basically every 6 minutes and 24 seconds, a pseudo-random process RANDAO selects proposers for each slot and shuffles validators into committees. This makes things a lot more random and a lot more secure. It's important to note about committees at every epoch, validators are evenly divided across slots and then subdivided into committees of appropriate size. All the validators from that slot attest to the beacon chain head. Each of the committee in that slot attempts to crosslink a particular shard. A shuffling algorithm scales up or down the number of committees per slots to get at least 120 validators per committee. Beacon chain checkpoints are really important. A checkpoint is a block in the first slot of an epoch. If there is no such block, then the checkpoint is the preceding most recent block. There's always one checkpoint per epoch. I understand that some of this sounds kind of confusing, but once you understand the terms, it's really not that difficult to understand at all. Let's talk about supermajority, a vote that is made up of 2/3 of the total balance of all active validators is deemed a supermajority. So for example, suppose there are 3 active validators. 2 have a balance of 8 ETH and a sole validator with a balance of 32 ETH. The supermajority vote must contain the vote of the sole validator. Although The other two validators may vote differently to the sole validator. They do not have enough balance to form a supermajority. So finally, when an epoch ends and its checkpoint has garnered a 2/3 supermajority, the checkpoint gets justified.